Hey guys, welcome to part two of the exponentiation unit for the CC Math Mat. So let's talk just a little bit of basics first. So with the number line, it's cool because in the past, with addition and subtraction, we had always illustrated, counting, and lots of kids have seen this before, where you're just taking the little steps one by one by one. And then multiplication was fun because it showed us how kind of we're skip counting and we're going by twos or whatever it is. So with the exponentiation, they illustrate on the number line as well. And it's really cool because that very first one, we're hopping, just one unit. And then we're starting, actually I should do it as they did it. We start at one. So the reason we're starting at one is because we can't, this is a little confusing, and we won't go into it in this video, but if I were to graph my exponential function, it will always go through the point 0, 1. And we're going to get into graphs here in the next few weeks. But what happens is there's no power I can take something to ever get it to be equal to 0. So anything to the 0 power is 1, and it will cross through, and then it will shoot up really fast. And we've kind of probably seen this graph before and not realized it when we talk about exponential growth. So, and when I get into fractional exponents, so or negative exponents, anything less than 1, it flips it. So there's a lot of things that go into this that make it really tricky, but we're not going to be starting on 0 in our number line representations. We're going to be starting on 1 because that's going to deal with our positive exponents, whether they're natural numbers, counting numbers, or they're actually are fractional exponents, things like that. So anyway, we're starting at 1. So let's say that we were going, this would be like 2 to the 0. And then we hop over to 2, and that gives us 2 to the 1. But then we have to take a bigger leap to get to 2 to the 2, because 2 to the 2 is 4, right? So 1, 2, sorry, my writing's a little sloppy. 1, 2, 3, 4. And then if we wanted to go one more hop to 2 to the 8, or 2 to the 3, we have 5, 6, 7, 8, because 2 to the third is 2 times 2 times 2. And that's going to be the easiest way, especially for younger ones, to understand this. It's just like before we learned multiplication, and now we're saying, okay, when we take it to a higher power, we're multiplying it by itself that many times. And especially because they have the cubes and the square songs in their skip counting repertoire by now, they are able to kind of see that concept. Oh, that one's a little different, and the numbers are getting big way faster. But I love this illustration. They're not even hops anymore, and they're just going to keep getting bigger and bigger and bigger and bigger and bigger. So that's why it comes across that way, and why it starts at 1 opposed to 0, like all the other number line representations. So let's talk a little bit about, I'm still just looking at page 1. So as we're doing this, I mentioned already the two rules that are going to be very crucial for them to know are that anything to the 0 is always going to be equal to 1. And it's a little bit of a tricky concept. There's some fun little proofs on it. If you go online and just Google why is anything to the 0 power equal to 1, there's some cool things. Maybe I'll do a video on it, but just know it's always going to be equal to 1. And then any number to the 1 power is always going to be equal to itself. So naturally, you're going to see when we go through the laws of exponents, you're going to see similar things, with identity, with, you just have 0 and 1 continues to pop up over and over again in different ways in math. So, but those are your general rules that are very important to know about exponents. Anything to the 0 is 1, anything to the 1 is itself. So as we are doing that, let's talk a little bit about, so there's this this one spot, and I'll just kind of do this this problem. So I have 5 to the 2. It says exponentiate is the first thing it says. So 5 to the 2, this is just 5 times 5, which equals 25. Then you have another one. It says rooterate. So it has square root of 25. So it's taking us backwards. So they already walked this process. So if they don't know their square roots yet, it's okay because they walked this process and point them to this is the same number as this. Now we're working backwards because the square root of 25, break it down again, and this is where you can review those prime factorizations that they've done at whatever level they're feeling comfortable with. Do some of these basic ones, and then if they're really feeling comfortable as you get into the higher roots, there's going to be opportunity where they can learn to simplify these as well. So this is 5 times 5, and we're just noting that, oh, these are pairs. So we're going to go to 5 because it takes 2 5s to make 25. When we take the square root, we're working backwards. Now, the one thing I didn't check in the answers, which I will, is that there's always a positive and a negative root because I could have done -5 times -5 and gotten a +5. And I could have also done +5 and or say that back. I said that wrong. -5 times -5 gives a +25, and so would -5 times or +5 times +5. And I'm looking at it, it's not doing that yet. So don't overcomplicate it for them. That's going to be more as we're looking for solutions. So right now we're just kind of walking through and following patterns. And then the last thing you'll see is where it says loggerate. So we have this thing, this is called a logarithm. And I'm sure at some point somebody will watch this video and has never seen this before. Or maybe you always saw a log button on your calculator and you had no clue what it was. Well, this is what it is. It's another way to represent an exponent. So what I'm saying is 5 to the what power is going to equal 25. So this is a way that you work backwards to find what is the exponent. So we learned multiplication, then we'll learn 3 times what number equals 15. And they, think backwards, or you solve the equation mathematically. What really happens is when you're solving it in your head, you're doing what algebraic process would do on paper in your head for more basic problems. So that's what's happening here. You're saying 5 to the what power equals 25. Well, if you know your squares and stuff well enough and your cubes, 5 to the 2 equals 25. So your answer is 2. So just like when we've talked about fact families before, and those of you who have worked through more traditional curriculums, you'll see the fact families with addition, subtraction, multiplication, division. This is kind of like a fact family right here. Do you see how there's a 2, there's a 2, and there's a 5, and there's a 25 in all of these, but we're seeing different ways that we can represent these things. Okay, so when we see the connection between these, we start to understand what are the laws that pertain to these things. So then on page 2, a lot of these where it's like simplify the powers, very, very good examples for them to be working. Again, do not stress whatsoever if they are feeling totally lost or overwhelmed with this, because this is a lot of new math. But as they're working these are the things that so many students have virtually no practice in when they hit higher levels of math. And it's where most students, unless they are very, very mathematically minded, just fall off the train and never get math again and get overwhelmed and don't want to do it anymore. So seeing this younger now and feeling a little overwhelmed in it is a good thing, because and know, especially if you have a 7th grader that's doing this in challenge, but you also have some younger kids who are starting early and following the process of the math map, it's awesome because they're already going to have that step ahead when they hit 7th grade, because they've seen this stuff in lower levels, they've played with it and so forth. So it's okay for your 7th grader, if you're in challenge A right now, to feel very overwhelmed by this and say, never did this before. And it's a good thing because they have plenty more years to work through it. And I can guarantee you 100%, even if you don't make it through the whole book, even if you don't make it through half each of the books, your student is going to be so much more prepared for higher levels of math doing this than anything you could ever compare to in other curriculums. At least that's my take on it, because I still continue to be amazed with how this whole process works. So, the last thing we'll talk about in this video is simplifying powers. So let's just talk about basic laws of exponents, and we'll stop there. So if I had um, 2 to the 2 and then to the fourth power, see how I have something to an exponent and I'm taking it to another power. This is where we multiply. So we would multiply the exponents. This would become 2 to the eighth power, because 2 times 4 is 8. Again, continue reviewing that this is why it's so important to have the foundation of addition, subtraction, multiplication, division before we get into these higher levels, because we have to understand multiplication to understand the laws of exponents, even though exponents is also exponent. Exponentiation is another form of multiplication. So then what if I had 2 to the 2 times 2 to the 4? Okay, see the difference? This one is 2 to the 2 taken to a higher power. So this 4 gets distributed to the 2 by means of multiplication. But if I have a 2 to the 2 times 2 to the 4, note this base has to be the same. This is called the base. I should have said that. The base and the exponent, okay? 2 to the 2 times 2 to the 4. Guess what we do? We add them. This is 2 to the 2 plus 4, or 2 to the sixth power. This is a huge hang up that again, just from a teacher perspective of higher levels of math, I see messed up all the time. So focus on this. I don't even know if it does it here on page 2. I actually don't see it necessarily. Um, it's kind of getting there. I know that it comes up later, but I just felt this was really important to understand just walking into this. So we'll finish this and then we'll move on to another video with more concepts in this. So 2 to the 6th. And then the last thing I'll talk about, what if I had, I'm going to put the bigger number on top just for simplicity's sake for the time being. What if I had 2 to the 4th over 2 to the 2? This can be easier sometimes once you see it real well, because you can illustrate it this way: 2 times 2 times 2 times 2 over 2 times 2, and then they've already learned how to cancel these pairs because they've been working on that with the factorials, and they've seen it already. But this is now just 2. But what is the act we actually did? We did 2 to the 4 minus 2. We subtracted the exponents. The one on the bottom you can always think of as negative. The one on the top is always going to be positive. So we have 2 to the 2. So a negative exponent then is, it will flip it. So if I have 2 to the negative 2 power, this is the last thing, I kind of promised that. 2 to the negative 2 power, this is the same as 1 over 2 to the positive 2 power, which equals, whoops, see how easy it is to make a mistake, 1 over 4. Okay, so it just flips it. If I did 1 over 2 to the negative 2, because you'll get this stuff sometimes and it's very confusing. I don't know why my 2's look different. 1 over 2 to the negative 2. Now this flips up to the top of the fraction and becomes 2 to the positive 2, which equals positive 4. So again, there's a lot of fun to be had with this. I know you might be saying this is not fun, but there's so much so many properties and things that go in with it. And just again, encourage your kids to have fun with it, not get frustrated when they think they have it right and then it's something totally different, and just continue to get used to this process and this new language of math that many never even truly grasp. So you're already ahead of the curve. So that's the end of this video. Check for part 3, and part 3 should go through the rest of the first 4 pages and then we'll see where we go from there. So have a great day. Thank you for joining us.